NumPy provides support for large, multidimensional arrays and matrices, along with a collection of mathematical functions to operate on them efficiently. Understanding how to perform arithmetic operations and utilize universal functions is essential for data analysis, machine learning, and scientific computations. Before we begin, as always, we need to import our NumPy library. So import NumPy as np, and we run that, and we're ready. Now, NumPy allows you to perform element-wise arithmetic operations on arrays. These operations are applied to each corresponding element of the array involved. First, we need to create two arrays. So we'll start off by creating our first array, which is going to be R1, and we'll use the NumPy arange to generate a list of numbers starting from 0 to 4. And our second array is going to also be generated with arange, and this time it's going to be 6 to 10, but with 11 because we stop at 10 and we do not include 11, so 11 is exclusive. Once we have created our arrays, now we can add the two arrays element-wise using the plus operator. So let's take a quick look at our arrays. So we have ARR1 and ARR2. And now when we do ARR1 plus ARR2, we get the addition of each specific column. So the first columns add together, the second columns add together, and so on. And we get this final value. So it's per element. The first element adds to the first element, the second element adds to the second element, and so on. Subtraction is also performed element-wise as well. So if we switch this around and do ARR2 minus ARR1, we get the subtraction from this and this, and it works exactly the same way. The same thing goes for division. So ARR1 divided by ARR2, and we get the division of each element. You can raise each element of an array to a power using the asterisk symbol twice. So if we want to take the first array and raise each of those elements to the second power, then we use two asterisks and it will square each of the elements. Universal functions, or ufuncs, are functions that operate element-wise on arrays. They are highly optimized and support broadcasting, typecasting, and several other features. NumPy provides a range of mathematical functions that operate element-wise. The first one is np.add, which adds the two arrays. So using np.add, we can add our first array with our second array, and that adds our arrays together. We can subtract the results using the subtract function. We can also multiply, and we could as well divide. And we could raise to the power, where we raise each number in array 1 to the power of each element from array 2. And when we run this, we get these values. And what really happens is this element is raised to this power, this element is raised to this power, and so on and so forth. NumPy offers trigonometric functions that operate on arrays. The input values are assumed to be in radians. So we could calculate the sign of each element within the array for each element. And when we run that, we have calculated the sign. We could also calculate the cosine. We could calculate the tangent. We can also calculate the exponential. And we could calculate the log. NumPy also has comparison functions that perform element-wise comparisons and return a Boolean array. So we could, for example, do np.greater, where we check where the values of ARR1 are greater than ARR2. And when we run that, we get an array. And of course, all the numbers in our first array are not greater than our second array based on each element. Similarly, we could use less, and that of course returns everything true because all the numbers in ARR1 are less than ARR2. That is specifically the first element in ARR1 is smaller than the first element in ARR2, and the same for each element-wise comparison. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.